Let's get started. Please download the material. It's just a small zip file. You just unzip it and then you get a PDF and view Python files. That's what we need. There's no other requirements. I'm going to use in Jupyter. If you like Jupyter, you can use Jupyter. If you use any other tool, use any other tool, whatever you like. We'll come back to this thing because people coming in, but just a quick intro who I am. So here I'm a Python user since 1999, so I can also claim since the last millennium. I'm using Python since version 1.5. Haven't found a better programming language yet. And I do Python training since 2004. That was more than 20 years now, if I calculate right. I'm running PyCon Academy, so I do Python training, and I have quite a few colleagues that also help me to do Python training. And these are trainer-led sessions like this, in person or remote or hybrid. And we do this as open trainings in Leipzig, but joining remote doesn't really matter where it is, does it? But also a lot of in-house training for companies, institutions in Germany and all over Europe. I'm also involved a little bit in other things. I still do some, from my background of hydrology, do some groundwater modeling, but I'm also organizer of conferences. So the first years I was mainly organizing. The first two PyCons DEs I was sharing and also organizing a lot. Was chair of the EuroPython once, and then also I'm the chair of the Python Software Verband. You might have seen me on the stage at the beginning. So we are a German non-profit that helps to organize conferences, just like this. And I'm also founder of the Python user group in Leipzig, and I'm a PSF fellow, and maybe a few other things I didn't write down here. Good. Back to the link. I would like to ask a few questions of you about your Python experience. So who has less than 1 year of Python experience? Please raise your hand. Only one person. Between 1 and 3 years? Good. 3 to 5? More than 5? Okay, so we are more experienced, and so usually it's more like an equal distribution about this. It depends how big I make the bins here, but then also a lot of people more than 5 years. In Python, so we are more experienced. And that's correct because this is more marked as an experience tutorial, so it's about descriptors, not decorators. So it sounds very similar. Yeah, so I also do a tutorial about decorators, but they're a little bit different. So this is about one feature of Python that's been there for a while, and I've been teaching this for a while, and people always tell me that's a more involved feature. So please download this one. So people still came in. Download this one, unzip it, and when you unzip it, you will get a PDF, and we will pretty much go through the PDF here. This is a write-down what we do, and I will pretty much stick to the PDF, so if you get lost, you can always go back with the PDF. All the code is available as Python files because copying from PDF doesn't really work. So there's something, so and I will go slowly through it. I don't throw big notebooks on you. I will go step by step. So descriptors. Descriptors, the thing is called the mighty dot. So every time you use a dot, you invoke a descriptor, potentially, in the background, some way. And we will look at what it is. And descriptors are used quite a bit, but usually don't see them. That's supposed to be this way. You want to hide things, yeah, in a good way in this case, behind this dot, what happens. And people always ask me for real-world examples. And I came up with one, and SQL Alchemy is using descriptors heavily, at least that's what they say on their website. And I looked in the source code a little bit, and I have an example here. So this is just to illustrate. You don't have to understand. If you don't know what SQL Alchemy is, you don't need to understand anything here. This is a real-world example where they hide complex behavior in the background. So essentially, this is an example where you make a small toy session with SQL Alchemy and a table here, so if you know this. And then when you access the dot, if you do something with a dot here and access a dot, then a lot of complicated things happen at the background. That's the main idea here. So they actually generate SQL queries or SQL statements or other things in the background to trigger something, and that's behind the dot. And the nice thing is if you want to change something, how things behave, it's not user-facing because you just write the dot and you don't see the changes. And when you look at here, generate a thing now, this one generates SQL, and you have this. So this is just a teaser. There are quite a few libraries out there that use descriptors, and we want to look at a little bit how they work. Good. If you would like to ask questions, you can always raise your hand. If it fits, I try to squeeze the question in. I might postpone the question to later, if I say, okay, we're going to cover this later. But I try to always incorporate questions if possible. So the first thing I would like to start with is properties. So I will develop new notebooks for each topic. In the back, can you still see it's big enough? Yeah, so of course it's difficult to see this. Okay, so I save the notebook. No. I changed the name of the notebook and called it properties. So we look at properties. Who of you used properties? I have to write it right. Properties. Who of you used properties before? Quite a few people. So a property is an application of a descriptor. It's a specialized use case of a descriptor, but it's good enough for many applications actually. So we will look at the property first, because it's a little bit simpler to understand, and then we go to descriptors, which is a generalization, and we see how a descriptor works. And during the training, we also look at the differences when to use a property, when to use a descriptor, when it makes sense. Good. So if you're so I'm doing this always in notebook, and I also will then in the end there are also we do an exercise, and there will be solutions to the exercises, and I will upload the solutions and these notebooks I develop here, just in case there's something new in there, to the same location where I just downloaded this stuff. So we have this. If you unzip the file, so I created an environment here. The Pixie file is not involved in this thing, but if I change to the property directory, I get these files, so you should see this Python files, and I'm just loading the Python file, and I have this example of a square. So this is a pretty good example of this property. So the property is often called a computed attribute. A computed attribute. So if I'm outside, you just see an attribute, but when you access an attribute, something happens. That's the whole gist of the whole tutorial. And the property offers this. So what I'm doing here, I have a square. Yeah. That's a rectangle where both sides all have the same length. And I make a class, square, and I provide the side as an argument. And then I come with a property. The property, it's a built-in. So in Jupyter, everything that's built in becomes green. So that's why it's green here, but not bold. The keywords become bold and green. So it's a decorator. So a decorator, I teach 3 hours decorators. What's a decorator? It's a function. It takes a function, returns a function. Yeah. So this principle has been possible in the very early stages of Python. Why has it been possible? Because in Python, everything is an object. So that's always the most important sentence. Everything is an object, and therefore functions or methods, which is the same thing, are objects. And so you can take an object and give back a new object. And that's what happens here. So this property that does something magic. We don't need to know exactly what's happening. Just take it as a recipe, you put a property, and the purpose is you don't need to understand what's happening, something's happening. And this changes the behavior. You see, I have a method called area here, and this area just returns the side squared, which is the area of a rectangle, yeah? So a square. Yeah? You have this, and then I have another function with the same name area. This usually doesn't make sense. If you have the two functions the same name, the second one will override the first one. But here, we put another decorator. And this is a little bit strange, because now this area is this area. So this area name appears here, and now this area grows an attribute, which is a setter. So a property per default only allows your read access. We will see this. But if you would like to regulate assigning, setting, writing access, and deleting, then you can add this setter and deleter here. And you see, now if I set it, I just don't save the area, I save the square root of the area, which is the side value. Yeah. So the opposite operation to the power of 2 is the square root. Good. And then I also override the deleter. You don't have to do this. This would be the default behavior, just to show you can interface when this attribute is deleted. So if somebody calls DL at the operator and deletes the attribute. Yeah. In Python, that's not very often necessary. I find myself using DL very, very rare, sparingly. If you write in a certain style, probably you don't need it at all. But if somebody tries to delete it, then you can interfere and do something. And the default would be that you cannot delete it, but I do this anyway. Good. Everything clear? Good. So now I can have a small test, which in this case, I would just uncomment the test. I don't want to execute the test. And I do the test by hand. This is actually better. So now I instantiate this, the square. And if you look at the square, now you have the side, which we just said, which is 5. And if I access the area, I do get the area 25. Yeah. So what happens if you want to? You can do some print debugging. In this case, that's okay here. Yeah. So you just say print, and you put some print in here, and you see what's happening. And you see when I access this area, this method area is called. There's no parentheses. The only thing here, I get rid of the parentheses. Why is this important? So in the beginning, you can start out just with a static attribute, a number, a list, whatever. And later on, you decide, that's not good. I need to do something when somebody accesses an attribute. But now I would need to change my API. I have to say to the user, now you have to put parentheses behind it to call it. And if you use this one, you don't. So that helps you to keep your API stable. You don't have to change your API. And you're free to change the behavior without impacting the user. Yeah. And if I now set this one, I can say square. And I can set my area. And this would invoke, let's say I want to have a 36. Then if I look at the square side, it changed, and you will see now it's 6, yeah? 6 times 6 is 36. It changed because through the mathematics, the integer changed into a float. If you want to keep the integers, you have to do some inspection and convert it, but I think integers and floats usually intermix very well in Python, so it shouldn't be a big problem. But that's the main behavior of a property. If I want to delete it, so if I use del and I want to delete my square and my area, yeah, then I will. This will be trapped by my del method up here, deleter. Good. So this is properties. They can be very useful, computed attributes, and you don't have to change your API if things change. So now you see now I have the name area 3 times there. That's a little bit unfortunate. Let's say this actually this is the main usage of the square. So I mix up the order a little bit here, what actually happens in the background, since this is a decorator, let's come up with a with another solution that's actually the same solution but a different spelling, different writing. I have the square without a decorator, and actually you can do this, and there might be use cases where this is useful. So this would be exactly the same here. This would be exactly the same behavior. So I have 3 methods now. I use different names. I don't say area and there's no decorator. These are just methods inside the class, and they do exactly the same as we did before. And then I invoke the decorator in this way. You can always invoke a decorator like this. So this is a function that takes not only one function, but many functions, and returns something new here. Yeah, returns something new. And before we use the decorator syntax, now we use this syntax. This can be useful if you do this automatically for some reason. You don't have to generate code that puts a @ sign at each method. You can just do something like this. That would work. Yeah, so you can keep the old method around and generate a new one if you like. In this case, this area would now be an attribute here, and you could use this one. And you see here, the name has to be fget, fset, and fdel, and you have to give it documentation, and I just take the documentation from this method. The .doc gives you documentation. Question?
Would an IDE get this documentation in the helping methods? So most IDEs, when I set documentation, it will not take dynamic documentations into account.
That's a good question.
For example, VS Code.
Yeah, I'm not sure if it should be smart enough to recognize that it's exactly the same. Writing a property and the syntax with add is doing exactly this. I'm not sure how smart those IDEs are, so I haven't actually looked at it, but hopefully they are. Yeah. So I would recommend using the syntax that's recommended. Yeah, But nevertheless, there might be use cases, like if you automatically want to decorate many functions, you want to keep the old functions around, you can generate these new ones with this syntax. So there might be use cases, because you don't want to repeat this by hand, because you have to put a decorator by hand unless you write them. You can write a class decorator that decorates a method, that's possible, but it's a bit involved, yeah? So it makes it more complex, and this would be easier. So there's always a solution, but if you're in doubt, use a simpler solution if possible. It's getting complex by itself, you don't have to make the more complex one. Good, but that's possible to do this. So now the problem, I have 3 unrelated methods here, 3 unrelated methods that fly around, but they're all actually one. So these 3 are one, but it's not really clear. Up here it's kind of clear, but you still have to look at the decorator, and they have the same name, which is kind of strange. So I have found another solution, which I have here. That's not a standard. The problem, it's not a standard solution. So I have this one, the nested. I call it a nested one, and this one is does exactly the same here, but it's different. So I write my own decorator, yeah, and I have only one area, and now I nest these 3 things. So the fget, the fset, and the fdel are just the same we saw before, but they are nested, and then I use locals. Anyone knows what locals does? Yeah, locals gives you the local namespace. So in this case, it gives me everything defined in here. So it gives me fget, fset, and fdel, and therefore it's important to name them just like this, because if you look at this, these are the names of the keyword arguments I need to supply. Yeah, and if I do this now, locals creates a new dictionary with all these entries in here, and then I have a decorator on it, and this decorator takes this area and returns a property, but here you see now I use a property syntax, and I just say names, and names it's a function call. This is a return of locals, and the double star takes the dictionary apart as keyword argument. So there's a few things involved here, yeah? So, but this would make it automatic. The only thing that's missing is a docstring, and I just take the docstring of the function and put it in, and you see this just names is just a normal dictionary. So we can run it, and then if you want, you can put some prints in here and you see how things look like. So this is not standard. So always the problem is not standard. If you do something, you have to explain it. It might be a bit more elegant, but it's not a standard way. Well, depends. Elegant is always subjective, but it's a way of doing it. We do exactly the same. So let's make our, I call it S2 here to give it this name, a square. If I have to execute this one, so maybe I could even give it a different name, might be a good idea. Square nested, yeah, and I call it square nested here, nested, and I give it this name. And if I look at the side is 25, and now if I look at the area, it's bigger, so it should be this one, yeah? So this still works, and if you want to know how it works, you can now put a print in here, and you see what the names is. So I say print names, and then you see the names, and I just re-execute everything, and you see now when I call it, I get this dictionary, and this is the namespace from this function. You get a dictionary with the fget, the fset, and the fdel, and then I adding the docstring in here. So you can automate these things if you want to. You can solve any problem with another level of indirection, and that's our level of indirection. So if you like it, it's nice. If you don't, just take it as an interesting side point. Good. This is properties, and we will see in most places you will get away with properties, but if properties are not enough, you can go back to descriptors. So the property is a special case descriptor, or application of a descriptor. We will see you can create the same behavior with descriptors yourself by combining a few things, and this is a very common one. So if you don't have a setter, this would be read-only. So if I only implement this one and not the other two, then you cannot modify it. Yeah, this is the behavior, and you cannot delete it. If you want modification and deletion in a different behavior of these, then you can implement them. So this is one use case. But with descriptors, you can have more use cases. I will show you a few applications. Good. Any questions so far? Everything clear? Yeah.
Hi, thank you. So in your deletion method, you now said basically it's not deletable,
Yeah.
but how would you actually delete it? How would you need to change the method such that you can delete it?
Yeah, you just do something. It depends, because when it would be deleted, but you could. Deletion is always difficult because you don't want to delete the method. The method will still be there, but you want to have some action. So depends on the context of your application. So deletion means this in my domain, then I do something. Because often you would do something with you delete a file in the background or delete some from the database or whatever you want to do.
Okay, I see. So it's not about deleting the method.
Yeah, no, it's about something. If it makes sense, if you say I delete something, I'll delete this attribute. Something happens in my domain,
so
whatever.
Like a side effect, sort of.
Yeah, some side effect you think that makes sense.
Okay, thank you.
It shouldn't be surprising for the user. Should be something that feels natural in one way or the other.
Mm-hmm. Yeah. Thank you.
Good. Let's continue. So I make a new notebook, and this would be now. We start with descriptors. So descriptors, can be a bit complex. Therefore, first, so this is a bit longer here. So if you look at this, there's a few more lines. And I would start with what's called a data descriptor. So I need to explain it a little bit until it makes sense. So I have a data descriptor, and that looks like this. So this is a class. But this class is never used as a traditional class. This class is never used on its own. It's only used as an attribute of other class. We come to this. So otherwise, it's just a normal class. And we have an init here. And we have a get and set. So that looks kind of familiar, but a bit different. So we have these dunder methods. So these double underscore, they're called dunder. And they are special methods. They have a special meaning. Yeah? So they're usually invoked by some certain kind of syntactic things, like the dunder add would be the plus. So if you use a plus operator, the dunder add is used. And there are many others, maybe 150 or so of these special methods, and they have a special fixed meaning. You cannot change it. So never invent a dunder name yourself. You never know. A new Python version might have this new dunder name, and then your program might have some strange behavior. And we have a get and a set. And this one doesn't do much. Just the get is doing some printing, just for informative purposes, and then it returns the value. This is a very common pattern, so this thing stores some kind of value, and then I return here, just to return the value unchanged. You'll see later, very often you want to do something with your value before you return it, or whatever you want to do, yeah? And then setting, and now here I'm doing something. In setting, I get the instance and the value. We'll see in a minute what the instance is. And then I try to uppercase the value, which only works for strings or for other objects that have a .upper method, yeah. So if it's a string, it will be uppercased. If it's anything else, it will just stay the way it is, yeah. And again, I can have the delete. I don't need a delete. We will see this delete is also very rare. So by all these cases, I haven't really found too many use cases of the delete. The delete is something that's not that common to my thing in Python. I don't use delete a lot. There might be some other applications where it makes sense, but deletion, if you write everything in the function and you leave the function, everything goes out of scope. You don't need to delete anything most of the time. Deleting things out of a list or dictionary is a bit different, but very often you don't delete, you use a pop or other method to get them out. So deletion is not that common. Good. Okay. Once we have this here, now I can actually write a class. And I call this with descriptor, just a class. And now the only thing is, that's usually how I use a descriptor. I make a class attribute, and I do this descriptor instance here, and that's the usage. Any other usage outside of a class doesn't make sense. Of course, you can make an instance, but it doesn't do anything useful most of the time. And now, if I make an instance, yeah. So, make an instance of my with descriptor. So, and you have to quickly. And then, if I access my attribute, you will see now it triggers a descriptor. This is a descriptor how this works. And now you see the print, and I get my 0, which is not that exciting, but I can go to this descriptor. And now let's look what actually happens in the background. So if I do the dot, then this little short line, what I'm doing here, happens. So Python uses type to get the type of the class. Then you have your class. Yeah. So of course, every object knows its class, it's a direct class. And then inside you have a dict. So this is the dictionary that holds all the data, all the attributes, and this is a mapping proxy, the read-only dictionary that holds everything in the class. So this dict, you can look at it, but please don't, you cannot modify it anyway, but some other places you might. These underscore things, you need to know what you're doing. Just to look at it usually shouldn't be a problem, but modifying things you really need to know what to do. Sometimes it can be, you have to do it if you do something more sophisticated sometimes, but most of the time you don't want to do this. You just use other methods to get there. But in the background, Python is doing this, so you go to the dictionary, and then it goes to the attribute, yeah? It goes to the attribute, and then it gets your attribute, which is a data descriptor, and since it's a data descriptor, it looks for the get method. It looks for the get method, it even knows, so it's interactively. Looks for the get method, you have this get method, and it evokes the get method, and now, again, it puts my instance, and it puts the class, which I need to get again, because I haven't saved it. So that's what's happening, yeah? So, yeah.
What would be an appropriate type hint?
I think you need to, do you mean of the return type? The type hint would be in.
I would like to provide a type hint to the class attribute.
It's an integer here. The type hint would be an integer because it returns an integer, I think. So. And if anybody has other opinion, I haven't even thought about it, but usually it would be just whatever it returns should be the type hint, because the method itself doesn't have, it's a method that you invoke, it's just a little bit different syntax, but what you get back should be the type, whatever you want to return, yeah? I think, yeah? Was a good hint for the type hint. Okay, good. So we go through it, this jazz. So this is just some theoretical knowledge. This is supposed to be in the background. You don't need, I have to look it up. You don't have to do this all the time, but you can work with it. So this is called a data descriptor because all these methods are present. And there's another one, and this one is a non-data descriptor. Non-data descriptor, and this looks different because it only has a get. So if it only has a get, I'm not there yet. I'm too fast, so forget this one. So because we need to assign to our attribute, forgotten. We need to assign to our attribute. So if I assign a 10 to our attribute, then you see it. This will be called, and if you look at our attribute, it is 10, and you get this output. If I assign a string, yeah? If I assign a string, and if I look at my attribute now, it's uppercased. So I do something. It's not very useful, but you see something happens now when I assign, I can do something. And if you see, instead of uppercasing, we could do some checking. Yeah? Check if the value is whatever we want, and if not, I raise an exception or do something else. That could be possible. So you can intercept this assignment process, and you can do something. SQL Alchemy is doing this, it intercepts it and generates, there's a question, generates SQL statement, so you can look at this. Good. There's another question. You see, we have half an hour already.
One question for the specific example that you showed here.
Yeah.
Would it make a difference if you also use the property and setter approach for the descriptor? Would that also work?
I think you can, a lot of these things you can achieve with a property. Yeah, so whenever you can use it, now just try to show you, the property is using this for you in the background. The property gives you decorators that's doing this, what I did here by hand, but there are use cases a property cannot cover.
Yeah, no, I mean actually, in the descriptor class itself, where you define the set and the get methods, could you, I mean, would the example work this exact same way if in the descriptor class you used property? And
I don't think so. You need to get and set as undecorated. That would mess up everything. You would get very strange errors, I'm pretty sure. So that's not going to work. No. So it's always, I always need to try it out, what happens, and then usually a reason afterwards, because it's really complex, a lot of things, but I don't think it's going to work, I'm pretty sure. Yeah, another question.
What if you make another instance of with descriptor? Is the attribute the same as the other instance or not?
That's good. Everything is a class attribute. It's a good question. We come to this. So everything's stored in the class, and if you want to store the instance, you have to go through some more hoops. I have some examples about it. So the descriptor always works for the class. So if you want to share something between instances, a descriptor is good. If you don't, you have to do something else. We come to this. Yeah. Good. So now we have this one, and now I come to the. I was too fast. I come to the non-data descriptor. Non-data descriptor. I think one is called overriding, non-overriding. There are different terminologies. So, anybody read Fluent Python? Yeah. So the Fluent Python for Luciano Ramalho, and he uses different terminology for this because he said it's not very. But this is the official one from the documentation. So I use it here. Somewhere in the PDF, I mentioned the other terminology he's using. So this would be a bit different. So if I have this non-data descriptor, so there's no setter, only a getter, and the getter for some reason adds a 10 here. And now I make a class. I make a class called add10, which I write here, and I have my attribute with a great name attribute, and I make a non-data descriptor, and I put it in, and then I have my add10, and then I make an instance of it, and if I access it, I have an attribute. Yeah, and if I look inside this the dict. So the instance also has a dict, which is attributes of the instance. You see, this instance doesn't have any dict. Usually, when you make an instance and you say dot, Python looks in this dictionary and looks for the value. Nothing there, so it goes to the class. That's standard behavior. So first, this dict first, and then it goes to the dict of the class. And since it's a descriptor, invokes this complicated mechanism to get there. Yeah, that's what happens. But if I have my class from before, if you look my class from before, this one, the dict is empty, nothing in there. But I use the attributes, and usually you get the attributes from the instance. This would be the instance attributes. Yeah. But now the instance is not there; it goes to the class because the descriptor works in the class. But if I go here now and now assign something to my attribute, since I didn't override. You see, I get back the 100 because now I didn't show the one before, but it adds 10 to it. If you look in the dict, when I assign to it, it doesn't assign to a class, it assigns to the dictionary. Yeah, so the reading goes instance first and then to the class. When I write, it only goes to the instance, it doesn't go any further. So it stores at some different place. Yeah, so you can have the same attribute name twice in this case. Do you want this? Depends. So you have to know what you want. There can be use cases for this. Yeah, there can be use cases, but there's always, if Python looks for a name, it looks in different dictionaries in different places. Python scoping is the same thing, locals, globals, built-in. These are dictionaries you're searching in this order. If you go to the method resolution order, same thing, you go to this thing. It's not, method resolution order is not a dictionary, but it's always Python looks for names in a certain order, and first you go to the instance, and if it's not an instance, you go to the class. And then you go to the parent class. Yeah? Good, that's what happens here, and this is something you need to understand this one. Once you understand, then you see, oh yeah, this gives me some leeway. We will look at some use cases, what you can do with them. Might not be clear right now, but I have some use cases where I combine these things. Yeah, good. One small side note, functions are non-data descriptors. So, is this important? Usually, not really, but it's interesting to know. But then you know how method binding works. So if I have a normal function, yeah, that doesn't do anything, it's just there. And if the function, you see, this has a get method, which is an indication that this is a descriptor. It only has a get, it doesn't have a set, that's why it's a non-data descriptor. Yeah. So if I have a class, if I have my class here, And inside my class, I call it a method, but it's still a function. It's still a function. Yeah. And now I can make an instance of my class. Make instance of my class. And of course, if I look at my class, then this method is just a function. That's what it says. So anybody knows Python 2? In Python 2 it said method, and the other, it wasn't called function, it was a different name. But since Python 3, so for quite a while, it's called a function. So it is just a normal function, and you can look at a function. Yeah. So, and if you can also say type, if you look at the type, it's the same thing. If you say my class, and you go to the class, and you look at the method, it gives you the name function. But if I say type of the instance dot method, then you see now it says method, and if I just get this representation of my method, then you see it says a bound method. So, but what does a binding means? Yeah, when I invoke a method on the class, I need to supply, so if I can invoke this method, it doesn't do anything, but to able to invoke, I just don't do anything. If I try the same thing on the class, this doesn't work. If I use my class and my method, and I put the parentheses, what happens? It complains about something with a self, yeah? Missing requirement self. What do I put in here? What self? The instance is a self, yeah. So that's how it works. So whenever you use this bound method actually has this self used up already, so to speak, yeah. So partial functional application, everyone knows, would do the same thing. So that's how it works. So when you call a method on an instance, this happens essentially, plus the other arguments you potentially supply. Yeah, that's what happens. And to get there, to get this behavior, the method is a non-data descriptor. So is it important? It's good party knowledge to talk about it. I'm not sure if the other thing, but why not? You know, we get some background here. So, and now the same thing happens. So I go to my type, and I do the same just again as before. I go to my dict. Yeah, I go to my dict. I throw in the name of the attribute, which is method. I say dot get a get, and I do this again. I put in the instance and the type, which is the type of the instance. So that's a bit cumbersome, isn't it? So if you just say dot, and that's much better. That's what happens. So now you know how this method binding works. Is this important? If you do some meta programming, so you write programs as modified programs, this might be useful because you might get a very strange error message somewhere, and you know, oh yeah, I do this. Actually, there's in the types module, there's a method called a method type, which is doing this binding for me. So you can convert a function into a method type on the fly. That's possible. So there's other ways of doing it to work with it. Good. That's the theory behind. Now let's see what we can do with it. So we know we can use properties, it's much easier, but we can also use descriptors to work with descriptors. So descriptors work in the class, and for this one I have what's called the class storage. Again, comment out the example here. So now I have this descriptor called class storage, and now I do a little bit different. So I'm actually setting something. Otherwise, before I set it to 0, just you couldn't change it. So I have a default value, which is none, but I can also supply a value. We will see in a minute where this goes. And then I have this get and instance here called instance and owner. That's usually some people use it. I use the same name here. We will see in a minute what it means. And here I just return the value to set the value. The descriptor doesn't do anything useful. You don't need a descriptor for this. But maybe later you want to change it. So once you have a descriptor in place, then later you can modify and do something here. But in this case, I don't do anything useful. So let's go here, and I just take my class here, and I'm lazy now, typing so much. And this one doesn't invalid syntax. Yeah, just my commenting was trick. So I make my class, which uses this attribute just as in before. Now I'm do this, and now I make two instances. I make two instances here. and again, that's a bit faster than typing. I make 2 instances, and then we look at the instance. And I can work at instance. I have my first instance, store 1 and store 2, and I can now assign the attribute is, since I have it's 10. Where does the 10 come from? Ah, yeah, because I put the 10 here. The 10 is from there. So the 10 is the default value, so it didn't assign anything. The default value 10 jumps in, yeah. There. And now I have this attribute, and if I look at store 2, it also has this attribute 10, yeah. And now if I change this one, store 1, and I modify my attribute, and I say I want 100, yeah. And of course, if I look at store 1, the attribute is 100. Store 1 attribute is 100. And if I look at store 2, what happens at store 2? If I ask like this, what should happen? It's also 100. So a descriptor works in the class, no, was a question. So now these instances share one value. Do you want this? Maybe. Most cases probably not, but if you want it, then that's what you have here. And you could save, like if all the instances need to have the same ones, you don't want to put the copy of each dictionary of each instance of many instances, you can share them from a class. That's usually one benefit of the class method. If it's immutable, it's no problem, yeah? But now I can modify it, I can take it away. So I didn't modify it, I just deleted the 10 and put it 100 there. So I changed the value behind attribute, and now all instances have a different value. And it doesn't matter what instance you use, you have this ghost effect on all of them. There can be use cases maybe if you want it, but that's a standard behavior. That's a standard behavior of descriptors. If you don't want this, I found 2 methods to do this. The first one uses a weak key dictionary, which is I have from this book. Somebody must have referenced the book. I think it's called Efficient Python or something. And I wasn't aware of a weak key dictionary before, but it was an interesting thing. So let's look at the solution with a weak key dictionary. Yeah, so weak key dictionary. So in Python, when you create an object, you create a reference. So if you don't know this, sys, I can say sys get ref count, yeah, and I can say give me the ref count of something. You see, this is immutable object, so it's not a good idea. So the ref count of any object, let's make it a bigger number, yeah, and I can say sys get ref count. You get the ref count at this get ref count of an object. You get the reference count of this object A. So this is very high. This is a 4. If you do this in a normal Python prompt, you get a 2. That I get a 4 is in some artifact from the Jupyter Notebook. The Jupyter Notebook gives a protocol that happens, and then ref counting in the Jupyter Notebook doesn't work. So you get always very strange numbers, and if I keep executing things here, all of a sudden the number will go up. So it shouldn't be a 4, it should be a 2 if you do it in a normal REPL in Python. Why 2? Because when you hand it in, you create so this ref count measures itself, so to speak. You get another. The minimum reference I ever achieved was 2. Never get less. Yeah, so that's a little bit tricky because it's. So every object has a reference counter, and this is a real problem. Yeah, because as long as the reference counter is greater than 0, this object will be alive. Whenever you create a reference, you keep the object alive. You can use del as much as you want. You're never going to del this. Only when the reference counter goes to 0, the object will be garbage collected. Yeah. So now we need objects that are internal objects that you don't want to keep alive if something else, because it's just an internal bookkeeping thing. Therefore, you have a weak ref module, and this allows you to create objects that don't have a reference count. There are quite a few things to it. They're not so easy. It doesn't work for everything. You have to look through. But now, since we want to do some bookkeeping internally for something, we can use this weak key dictionary. So if I put something in a dictionary, it will be in a dictionary. If I delete this object, it will disappear from the dictionary immediately. Yeah, that's the whole thing. It's a bit tricky, but it can be used. That's what I'm doing here. So I have import this weak key dictionary, and now I use a hidden. I have a dictionary, and just think of it just a normal dictionary. The only thing it doesn't keep a reference. Everything else should be the same. And when I get it, I don't get it from here. I just go to the dictionary, and I go to the instance, and I try to get it here. So now the instance of a class serves as a key in a dictionary. This works. So instances per default are hashable. We come to this, there's some small problems here, but for now it works. So instances are hashable. Yeah, so you can always try hashable. Either you put in dictionary or you use hash, and you see if it's hashable or not. And that's what you need. So instead of storing everything in here, now I have a dictionary, and I use the instance itself as a key in a dictionary to store everything. So I didn't invent it. I just found it somewhere, and I thought it might be interesting. And now when I assign it, just this hidden just behaves like a normal dictionary, the same syntax here. And the get means I get either the instance. If the key is missing, I get a default. Yeah? So every dictionary Python has a get method, which is the same thing as try, access it, and then accept, give me back a default. That's what get is essentially doing. That's what I'm using here. So and if I execute this one, and I go to do the same thing again, so I make a class, and I make 2 instances. So I don't want to type so much. So here, I make a class and 2 instances, and I have to fix the indentation here. Yeah. Didn't I execute the cell? Did I forget something? The indentation is wrong? No, store name is missing. Name store, what did I do? Huh? No, never do live coding, huh? What? There shouldn't be indented, yeah, thank you. The indentation thing. Good, so obviously, that's in the class, and that's I make instances. Thank you very much. So now I have the store once, and if I look at this now, I can do the same game as before, and I have my attribute here, and you see that the attribute 1 is a 10, and if I have my store 2, the attribute 1 is a 10, and if I change one of them, yeah, then store 1 has changed. Store 1, attribute 1, changed. And if I look at store 2, attribute 1, it hasn't. Yeah, because now everything is stored in a dictionary, and you can work with a dictionary. Yeah, this is a very common thing. Very often in Python it's called wrapping. You have a class that sits in front of a class and stores the value internally somehow. That's kind of similar to this case here. So this descriptor has a dictionary, and for all instances that are created, it puts it into the dictionary, and then you can get it out of the dictionary. The thing is, if you do this and you delete the instance, you will keep the instance alive in a normal dictionary because you have a reference here. If the instance is deleted, it will disappear from the dictionary. That's the whole thing why you use a weak key. Otherwise, you have a built-in memory leak. Yeah, so you have a memory leak once you build it in. So this is nice, but a big but that has a problem because you can break it, and I have an example here how to break it because weak key dictionary break. Yeah, and the thing is, if you either have this hash implemented and arrays not implemented, or the equal. So if you look at if you look at the documentation about hash values, it's a very long thing. It's not so easy, but you make your instances non-hashable different ways, intended or unintended. So there's no guarantee that it works for everything. So if you give this to somebody and somebody makes a normal instance, it works. But if somebody does either of these methods here, does in this way, then the thing is not hashable anymore, and my nice approach just explodes. Nothing works anymore. Yeah. So if I do this, now I can keep this in here because you see, if I do this, I get a not implemented error because it's the hashing is called. So my whole this is intended exception now. This doesn't work because if you want to look into this hidden thing. you cannot put the instance in as a key because it's not hashable anymore. Yeah, that's a problem. That's a small problem. Good. So I have my own solution, which actually I had before, and I call this instance storage. Yeah, and my own solution is a bit slightly different. So I use the UUID module, which gives you some use. So instead of using the instance as a key, I store everything in the descriptor, in the instance, sorry, as an attribute, but I don't want to make the attribute accessible from outside. So in Python, there's no such thing as making things private, but you can make it very, very clear that it's not supposed to be used, and that's what I'm doing here. Yeah, so using 2 underscores does name mangling, if you know this, so it puts a class name with an underscore in front and something, so you can still access it if you like, but it's a big red capital letter thing, don't do it, yeah? So that's what I'm doing here. So in Python, you always say we're all consenting adults. You can always do something very stupid if you want, but there's big red things that don't do it. If you write a test and you want to test your own thing, it might be fine, but if you use a library, then I think there's no use case that you do it. You work against the library if you do something like this. So that's what I'm doing here. I have a hidden name. I create a name, and this name will be the attribute name, and I use every time, I use the same name for instances, but this is a very, very long string, very random string. Yeah, so there might be different ways. It should be long enough. Yeah, they use your MAC address and the time and all kind of stuff, and this should be. Yeah, and then you can do this, and then I save everything here, and then I go to the instance, and this would be instance.name. So this is the instance.name, but programmed. So get attribute, this means this object dot this name, and if it doesn't exist, the default. Yeah, so it's a try except, actually, it's in there. And when I say set, I say instance.name equals instance.name. Yeah, okay, let's do this step by step again here. So I go through, now I have this one, and I create my class and 2 instances. And hopefully I can do this, and then the indentation is correct, yeah? So I have my instances, and now if I can look in my instances, and I can look inside, I can say store 1, yeah? And if I do this, I get the attribute. But if I really want to, I can say store 1 dot double underscore, and I should get this long name, so I don't know what the name is. It doesn't show me the name. Yeah, store, I have to put the class name. Class name, how do I get this thing? What did I? Yeah, let's look in the dictionary. We look dictionary, then we have it. You need to guess, it's just in the dictionary. So you look in the dictionary is empty right now. Yeah, because I'm in the class, but now I can actually set the value. I set the value, the attribute value, and I go to the setting and say, okay, I want 100. And then if I look into the store 1 and I access the attribute, I do get the 100. And now if I look at the dictionary, then you see I have this very strange name inside. So I have this attribute now that exists. But this is very obvious, it's not for human consumption. Yeah? So I store this in the instance and I access it from there. But it's not designed for direct access. So you can break it if you access it directly. I can modify the dictionary. There's no protection whatsoever. But this big red thing, don't do it. Yeah? So that's very, very common in Python. If you do a lot of meta programming, you can always break Python. There are some programs where people say 1 equals 2 is true. So and that doesn't take much. You just take C types and you modify the references of 1 and 2, and then it works. Yeah. So if you can always break things. But if you want to do something correct, that's going to work. So that's my solution. I don't know if it's a good solution, but it works. So you can use instance storage to store something in the class. Yeah. So again, if properties are good enough for you, use properties. But if you want to know more, this is how you can work with the descriptors. Good. Any questions? Everything clear? Let's do some use cases, because I have some use cases.
Thank you. So we've seen a lot of sample applications now, and we're going to use cases. I'm curious, do you have a definition of what a descriptor actually is? Like if we had to give a definition to it, how would you describe it?
It's regulated attribute access, I would say, as one word. It's not like mathematician has this long definition. No, this would be my definition. You can intercept attribute access, reading, writing, deleting attribute access. So that's what it was. Yeah.
Perfect. Thanks.
I have one question. I think most of the things that you're doing here, you could also do with the dunder get attribute method, right?
Yeah, the dunder get attribute is very strong. So the dunder get attribute has the highest precedence. This will be used always first. And you have to be very careful to not get into recursive stuff because it will intercept all these get attribute things. It would work for the get, but it wouldn't work for the set. Because we also can intercept setting. And very often it's a combination of getting and setting, what you implement where and how to do it. We will see some use cases. You can implement both of them, one of them, and then you can have different use cases.
Okay, I guess my question was, what is the reason why you would prefer one over the other? I assume from what I see that it is using a descriptor is like more self-contained, that you have all that has to do with this.
The advantage of a descriptor, you can reuse a descriptor different places. You write a descriptor here and you can use it all over the place. If you put it in your class, you only have it in your class. And if you want to use it, you would need inherit from the class, but you don't want to inherit from some random class from somewhere else. That's usually not good. So I show you a lot of things, and you might achieve the same thing for special purpose with totally other methods somehow. But the descriptor can be reused over your code base, and you have more possibilities for things. If you don't need them, and you think it's too complex, don't use the descriptor. I just show you what it's all about, and then you can decide yourself if you want it or not. And there are usually 2 or 3 methods doing it, but that should be one obvious way to do it. What's obvious is subjective.
One more question. If we go back to the class data descriptor in a datadescriptor.py file, so we use this approach, and many times when I'm looking for, when I'm browsing through source code, I just want to see the help. I want to see the description of the class in some code base, and I use the help function, the built-in help function of Python. And when I use help for this class, data descriptor, I get 4 times the print data descriptor, dunder, get, dunder, and this happens 4 times, even though we only defined this dunder get method 1 time, but it gets printed 4 times. Why does it happen?
I don't know what gets printed. So this, in Jupyter, I use, or in IPython, I use a question mark. Should be the same thing?
No, so, I'm talking about the instance of...
the instance, okay.
So first we instantiate the class, and then we use the help function to see, and yeah, exactly. You see? Why does it get printed 4 times?
Yeah, because it's somehow when I access it, so this help is doing this help inspecting it, and every time it's inspecting it, it goes through my getter. It invokes my getter every time. So now we have to look at help, what help is doing, but help needs to look and creates all these, and for this one it has to inspect it, and every time it inspects it, it creates it. So the dot is also, if you use the built-in function get attribute, is the same thing as a dot. So if I use get attribute, it should have this. So I have this, if I have my W here, and I say w.attribute, you have this, and you should be the same thing if say get attribute, get utter, built in, W, and then you put it as a string. And that's probably what the help function is doing, and it just invokes the descriptor. So this is an artifact because I put the print in, so in your real code, you wouldn't put a print anywhere. It's just to show that something happens. Yeah?
Okay, thank you.
So I would need to look at the help, but it's probably inspecting it multiple times, and every time it goes through this descriptor. Good. So you can always experiment and look at how this works. So let's look at some use cases. So I digged out some use cases. These are just examples. Of course, you can hopefully adjust them to your own use cases that are the same or the very similar kind of tasks. So I say load, checked. So this is type checking. Of course, in Python you have type hints now, but here this is just an example. I could do my own type checking if I wanted to, and I could extend it in many ways, and this would be a runtime thing. Yeah? Python type hints are usually at compile time, and you use a tool like MyPy, but here I wrote my own thing. So it is a bit more complex. So I have I use my UUID approach here because I store things in instance, so it incorporates what we just saw before. And then I have my init, and here I can provide a checker. So a checker is supposed to be callable. Yeah, so usually you say a function, but when you say a function in Python, most of the time you mean a callable. There are many other objects that can be used just like a function, but they're not actually type function. So that's called a callable. So I have a checker, and if there's a checker, I just call the checker. So let's say the checker is int, yeah? And then I would call int, and if I call int on a string int, it would work. If I call int on something that doesn't, then you get an exception. So this would be pretty much, this would be one example of a checker. Of course, you can write your own function. So int is not a function, it's a class, but it's a callable. So, and then this would be the check. I try to convert this object to this data type I want, and if it doesn't work, I get exception. So that's the thing here. So, and then I store my checker, I store my default, and I do my hidden name business here. Yeah? And then I do the same thing. The getting is just what we had before, nothing new. So if you wanted to, I could have inherit from the other. You can inherit descriptors, yeah? But I just write it here to make it easier. So the get is the same. And then the set would also, if the checker exists, so if this is, so it has to be callable. Either it's none or callable. So if it's something else, you get a different exception, of course. So if it exists, I call it here, and I just do the checking. Yeah, you can do anything what I want. And this one is supposed to raise an exception if something is there that you don't like. And then you do the iterate. So this line is read before. The only thing new is applying the checker on the setting case. So now I have my own function is int. Yeah, wouldn't be even necessary. I could use it indirectly, but I want to have a nicer error message. So, and I say if this is not an instance of int. So if you do typing in Python, if you do it at all, most of the time you want to have is instance. Yeah? Type is very often too narrow. If instance would also check for the parents. Yeah? So if it say is instance file not found error will be instance of exception. So if it's then all the exceptions, if there is instance of exception, there would check all of them. If you just check one, check the type, that might be too narrow. So I check for this instance and I raise an exception. So this would be my business logic. So this is the difference, the different level of programs in one program. So when you program, very often you have different heads. When you write a function, you develop a library, and when you use a function, you use a library. So at a very small level, though, this is always how I think. And this is something you write once, and then this is the next level. These functions will be changed more often. So this descriptor will be there once, it doesn't change. And then for every use case, you write a different checking function. Yeah, that's something you can do. And then you apply this checking function to your class. And you see now, I use my checking function is int and default to 10. That works. And then I just default to 12.5 without any checking. Yeah, so even though it's called check, it doesn't do any checking because I don't supply any checking callable. And then I try to do something like this. It doesn't work. That's why I put it into try except to show you this wouldn't work, because now I use my function here and I get a default of 12.5. And if I do this, it jumps into in here. You know, in here. This is a setting. Yeah. So this equal sign invokes this setting. And since now I supplied the checker in the beginning, yeah, this is a class. So this here. Yeah, this checker is int is set, and then it goes through, and then it tries to convert the 12.5 into an int, which doesn't work. Yeah, so because 12.5 is not the instance, it would work, but 12.5 is not the instance of int. Yeah, so it says is instance 12.5 on int, and this is not the case, and then it's false, I raise an exception. That's what it's doing. Good. So. And if I run this one, then you see, now I can execute the whole thing. It cannot be set. And if I work with this later on, it's impossible. You cannot set it because you have this checker in place. So 3 levels of code. This one you could use from a library, yeah? And then you would write your own checker or checkers, and then you use it somewhere else. And this is not restricted to type checking. You can do any kind of checking, yeah? So you say, okay, that has to be a value between 0 and 100, or no, this test runs so long as Friday afternoon, I don't run this test now, or something like this. So you can do anything you want, yeah? This is totally up to you, and you can inject it there, and you can do it. You see, writing this class is a bit work, yeah. But later on, can you reuse it? If you do things only once, it might not be worth it to write a descriptor. But I have this here and here and here and here, pretty much all the same, and don't duplicate code. You can always write a helper function, but maybe a descriptor is nicer, and then you have only this checker, and then everything is just when you assign, it happens, yeah. And you can do this. Good. This would be a use case. So how much time do we have? 20 minutes? Yeah. So let's quickly go through. Now I have some section about them in the PDF, when to use things and when not to use things. When use descriptors and properties. So when the property does a trick, use a property. It's easier. But sometimes it doesn't work. I will show you, we have a few more best practices or use cases which we can see, which we cannot do with properties. So the property you have to tick explicitly in all of these places there, yeah. And you cannot use properties across different classes. The same property, if you want to use a different class, you can inherit from it. But if those classes are not related, you don't want to create relationships between classes just to reuse a property. That's usually not good, because you have a class diagram, all the classes are related for no good reason. So you don't want to do this usually, yeah? So, and therefore, if you have this use case in the descriptor, and there are a few things, sometimes you want to have a different behavior. So the standard behavior is you only have a get, and you can intercept the setting and deleting. With descriptors, you can get different behavior. We'll see in a minute. Yeah, good. So try to use a property if it doesn't work, or if you say, okay, I have the same property here and here and here, and these classes aren't related, and I need it in my whole code base, then you say, okay, I put a bit more work and write a descriptor, but in the end it's less code because I don't have to duplicate it. Yeah, of course, you can always use it, write a function that you import, and then you use a function in a property that will also work to some degree. It's not a clear cut, but the descriptor is an official way of doing things. Good. I have a few more practical tips. One of them is called the same name trick. The same name trick. So everything I show you now is just a combination of things we did here, but maybe with some ideas what you can do with it. So the same name trick, and I call this thing a %. Yeah. Example of the same name trick. So this is from Luciano Romalo's book. So let's say he calls the same name trick. So I just use a different example here. And I have a %. You see, now here I have this descriptor, and this is new. You have this standard set name. A few Python versions before, I had to go to some hoops, and you have to say, okay, this attribute has to be the same as a string, and so on. Now it's easier. You have a set name, so you can just use set attribute name here. We will come to this in a second, what it means. And then over you have a setter. There's no getter. This is not possible with the property, because the property by default always starts with a get. Here I drop the get, but only have the set. Different thing, yeah? So, and then when I set it, I do some checking. I say my value is supposed to be between 0 and 100. If not, there is exception. Otherwise, here I need to say dict. So I always preach, don't do this. Here I have to do it. So usually you say instance name equals, and here I want to write it directly in the dictionary. Because if I don't do this, I go through my descriptor protocol, which I don't want to. So I write it direct to the dictionary in this case. Yeah. So most of the time you don't want to do this. Here I think this is the way to go. So this is something might take you a while to experimenting how things work, but I write directly to the dictionary. And now I have a class with %, and if I do this, yeah, now I have this attribute %, and I have the same name check. You have to use the same name here and there to make this work. And now if I have my call P here with % thing, so I do this class and I have to give it a name, and if I do 34, that's totally fine. If you look at the attribute percent is 34. If I try to set this to a value outside of this range, yeah, so some people over there give 110%, so this is not allowed here, then you get this exception. So how does it work? So this obviously goes through the descriptor. If I try to access it, I don't go to the descriptor because this is stored in dictionary. So if I do this, yeah, I look in the dictionary first, so I get the value from the dictionary, but when I set it, I go to the descriptor, which in turn sets it. So there's no class storage involved here. Everything is an instance, but you have this checker before you put it in. It's called the same name track because you have to use the same name here and there. Yeah? And before you had to use a string, you have to put the string percent in here, but this set name is used, so it sets the name, so I can use this attribute set name is attached to this thing, and this is a string percent, and this is important to use the string percent. So this is a bit involved, but take it as a recipe, say, okay, I have a similar use case, I can look at it and then just modify a few things, and you don't call it percent, you call it something else, and then you would have this. This thing is that you have to use the same name, that's all. Yeah? So this is something you cannot do with a property because I only have the set, but not the get involved. Good. Yeah, so if you want to have a read-only, that's a problem. Sorry, if you want to have a read-only, then you need to my read-only. That's my read-only. Yeah. So you want to have a read-only attribute. Yeah, and then it's a problem. If you just say, okay, I want to read it only, then I only have a getter, but I don't have a setter. This doesn't work. Let me see in a minute why. If you want to do it correctly, you have to implement the set, but raise an attribute error. Because if you don't have the set, if you don't implement the set is just going to standard procedure and nothing happens. Yeah. So if you want to prevent writing to an attribute, make it a read-only attribute, then you need to do this. This is something a property can do. Yeah? If this would be the standard behavior of a property, if you don't implement the set, the property would have its own set and just say, okay, you cannot do this. Yeah? So this is just an example. Again, you can do this with a property, but here it would be a reusable, and you could reuse the whole code base without inheritance, without re-implementing. Yeah, another question there?
Just about the pattern, I think in other places I often see setting a function that is like prohibited from access to none. Would that be possible here too? Or is this just a matter of choice?
I didn't really understand the question. You said which function you set to none?
The dunder to not have here a dunder set raise attribute error, but dunder set equals none without the def.
Yeah, that would be the same thing. Then you try to call, but then you get an error message. None type object doesn't do this and this, which is not very helpful. Right. And here it's about the exception. The exception is more descriptive because I raise my own description. Otherwise, you get this very, very famous exception, none type object, and you get 10,000s of questions Stack Overflow about none type object is not able to do this what you want. Yeah.
Okay. Thanks.
Yeah. It's about the exception being more descriptive. Good. That's one use case. I'm quickly go through. And then we have one, this is caching. So, and then, well, it doesn't work, cached. Yeah. So you can also do caching. That's one way of doing things. So if you don't want to recompute things, you can do caching. Yeah. And again, I use this set name, so because I use the same name tag thing. And now I have the get. Yeah, and I check here, if there's no instance provided, I raise a value error. And here, the first time I do some expensive calculation expensive calculation, and I put the calculation in the dictionary of the instance. So the very first time I go to an instance, there's nothing. I do a computation, which is represented here by printing, and the next time it will be in the dictionary. Yeah? Okay, let's do this. So we make a class with cache here, and with cache, and then I have my instance here. Yeah, and now if you look in the dictionary in the beginning, it's empty. Dict is empty, and then now I can access my attribute. As I access my attribute, you see that access my attribute is doing some expensive computation here. And if I look at the dict again, it will be in the dict, and next time I access it, it will take directly from the dict and circumvents my expensive thing. You can invalidate the cache by deleting it out if you want. You get more fancy, yeah, if you want. This would be one way. Of course, Python has a decorator called LRU cache, which is pretty good for most of the things. This would be a different thing, attribute access. Again, nothing new. We've seen all the bits and pieces before, writing a dictionary, and this is a way of doing it, and you can say, oh, only compute it the first time, but you could also have a person in the background say, okay, if it's older than, in addition you put a timestamp, is older than a minute or 2 or 5, then I do the computation anyway. Then you would need to delete it. Here in this case, you would need somebody to go there physically and removes it from the dictionary, otherwise you wouldn't be able to do this. Yeah. I would think through how to do this exactly, what would be a good thing, but it's certainly possible to do it, but you would need to do some extra steps from outside. Good. So, okay, we have one more topic and then we have exercises. So we have, how much, when we did start? We start 15 past, so it's 15 minutes, yeah? Okay, so I have one more thing about special methods. I'm just checking because it's pretty big if I want to go through. So special methods are these dunder methods. And yeah, so let's see, I have a class that has a special method called contains. Yeah, and contains is used when you use the in operator. So if contains doesn't exist, it might go for some different, but this will be the first thing it will call when I use in. Yeah? And now I can make an instance. Let's do this. Again, take this out here. Let's do this. And now I make an instance of my special, and I can look inside my special. Yeah? And if I say something in my special, ABC, in special, then I see it says true because it always returns true no matter what I'm doing. Yeah? But you see the side effect, it prints got ABC. Now this in invokes this contains method. Yeah? It contains method. Yeah? When I assign to it, which I can, you shouldn't do it, when I assign to it, it still works because the in doesn't look in the instance, it goes to the class directly. So special methods go to the class directly. And now, of course, if you look in your special, you have this stored here. So the dict does have the contains, but this one is not used when you use in. If I call contains directly with the parentheses, it will give me an error message. Yeah, we'll say now int object is not callable. Yeah, so you have to be careful. Those special methods don't go through this normal scheme, instance first, then class. They go to the class directly. If you invoke them with a syntax, if you invoke them with a name, then you will get so because let's go back. So if I do this, I make the instance anew. You see, if I do this anew, this would be the same as saying special contains contains ABC. Yeah. This would be the same thing, but once I assign here and have this one, and now I do this again. Now I get an exception. Yeah, because before the dictionary was empty. So do it again. Special. The dict is empty. Yeah, the dict is empty. So we always go to the dict. The dict is empty. So this one goes to the class, and then it works. If I assign it, the dict is not empty anymore, and now this one breaks. Yeah, be careful how this works. So special methods are special, and you can work with it. Good. I have one more thing with protecting it, but that may be, yeah. It's a very long one, and I have to do method binding and so on. Maybe it's too much, because there's a lot of examples here, applications we can have, and you can work with it. When does it end? How long do we have? 10 minutes. So 10 minutes. So there's not much time, because I also have an exercise. So usually I have a bit more time for this, but it's fine. So we have an exercise. Let's quickly go to the exercise, and then we have time for questions. So if you want to do the exercise, please do them. I will supply solutions to it. So this last thing I didn't manage, but that should be fine. It's pretty complex, so let's go through. So the exercise here, you can write a descriptor that can only allows positive numbers to be set. So you could use properties in some places, sometimes use a descriptor. This one we code for descriptor to exercise a little bit, and then when it returns, do round it to decimals, and then prevent a deletion. That's easy. And then this one would be interesting. This would be a reusable descriptor. So you have, if you're in Europe, every country has different VAT rate, and now we create a descriptor that we can use to. It takes the VAT rate, like Germany 19%, and some other countries, most countries have more. Yeah, and then when you access it, it actually gives you the net price which you put in and the gross price including VAT, and you make a class for each country, and then when you access something, it calculates this one in the background. That would be just a simple example. So usually we have half an hour for the exercise, so in 10 minutes it's just unrealistic to get through. Please try. I will supply the solution document where we have an example solution to go through, but to go through the solution would take me another 10, 15 minutes to explain this. We don't have this here, but hopefully you get the gist. Take home message is, if you want to do something, try properties first. If they work for you, you're done. If they don't work, analyze your problem and say, why does a property not work? Doesn't work because I need to distribute over many classes. Then you have to go to the descriptor, or I have a use case where this getting doesn't help. I only want to use the setting mechanism. Then I also need a descriptor. Yeah, so that's pretty much a take-home message. Otherwise, it can be pretty involved, but you always can take these as a recipe and apply it to your problem. All the technical things are in there. It's just a question of what you want to achieve. And of course, probably you need to write some tests to really see if it's doing what you want. So of course, this takes some experimenting if there's not a corner case I've forgotten somewhere. Good. We still have 5 minutes. Any more questions about anything? Also from people online, so I don't see you online.
No, there's nothing on Slido.
Oh, okay. No Slido questions?
Yeah, so first of all, thanks a lot. I think for someone who is not that experienced in Python, it was also nice to just get a better understanding of how it works under the hood. Now my question is, there are obviously libraries that already do some stuff that you showed, for example, checking that a value is in between a given range, so yeah. PyData can do this. Would you actually recommend using custom approaches like this? Or would you recommend to use like libraries like PyData or I guess MyPy or something like this?
The answer is always depends. No. Yeah. So if this one has advantage, it's built in Python, so it's not going to change. So Python's not going to change. If you use a library, then you have the normal thing. You have a dependency. If you use PyData anyway and you depend on it, it doesn't matter. But if you just for a small thing install PyData, yeah, dependency stacks grows just to have something. So that's the thing. There's always different ways of doing it, and it depends on, you have to analyze your problem and then make a list, advantages, disadvantages. That's part of Python, that's a SQL library. Patentic can do this much better than I can do it, then use it. But Patentic does something in a different way I want to do it, and I would need to change the way of Patentic is doing it. Maybe. So there's no clear-cut answer for these things. And things change. So that might be correct now, then your requirements then changed. You want to do something more, and then the situation might be different. So there's no yes or no answer here.
Thank you.
Anyone else?
Yeah, there's
Okay.
one. We still have 4 minutes, so I try not to run over because people want to have breaks.
Yeah, thank you for the presentation, first of all. I have one question. What confused me a bit is usually I try to think of class variables as variables that are shared. So there's only one, and there's instance variables that are not shared. And now you showed us a kind of complex mechanic to have class variables that are different for each instance. Do you see a danger if someone else reads my code and thinks it is a class variable, and then in the end it's not really?
Yeah, so depends who our users are. So if the user is using a class and everything feels natural, it's fine. So depends on the domain of the user. So I work a lot with scientists and engineers. They use programming as a tool, and they don't care about all this fancy details. So they never will write a descriptor in their life, I'm pretty sure. So, and if it works naturally for the domain, it's fine. If you do something unexpected, it's not good. That's my rule of thumb. So if you overthink about why does it, I don't understand. So you want to hide complexity in a good way. So you give the user the least surface to work with, and it works correctly, and you do all the complicated stuff in the background. If this is achieved, it's fine. If it gets complicated to the user and not understandable, then you did it the wrong way. Yeah? And of course, it's not really clear, but now you still store it in the instance, but in a different way than the user did. It works directly, but a lot of users don't know about the dict and the dicting class and all these kind of things anyway. And now we change this behavior to check for values. At the end, the user gets exceptions, say your value is not correct, and that's what counts. And how you get there, as long as it works for the user, I think it's okay.
All right, thank you.
There's another question there. We still have 2 minutes.
Thank you. Thanks for the talk. Yeah, it goes somewhat in the same direction as the previous question. So I think this descriptor framework is pretty powerful. I'm just wondering conceptually, if you want to control the attribute access really on the instance level. Now you showed these tricks with the vgraphs and these UIDs. Why conceptually don't descriptors work on the instance level? Why can't I assign a descriptor to an instance attribute?
Yeah, so because usually all the methods, you could do other tricks. You can assign different methods to different instances programmatically, or so there's different ways. But the descriptor protocol is used in Python anyway for a lot of things, and though you can use it, but you can achieve similar things. You can do a lot of meta programming. Yeah, you can have a class decorator that decorates all the methods, and then you can also, if you wanted to, have after the init do something after init and then modify all. There's a lot of things you can do. I don't think they are better because the more you invent, the more you can do wrong. And descriptors are a part of Python internally, and that's well proven. It's not easy, but they should cover all the corner cases. So if I come up with some own smart solution, I find out this corner case and this corner case and this corner I didn't cover. So and that might come much later. So I think that's probably the reason to put all the methods in the class. You can put methods in instances because you need to have a computable something. And usually all the methods are in the class, and it's a good way to do it. There are certainly other ways to achieve the same thing, but this is something there's a long explanation in the standard library, the standard documentation.
Thank you.
Okay. No time left, I think.
Time is up, yeah.
Okay, time is up. Thank you, Mike, for this extremely interesting tutorial. Well, once again, thank the audience for all the questions and their participation, and have a nice day.
Thank you.